my name is Stan Bianquist. Welcome to Guitar Talk. And we're going to talk about another instrument in the guitar line, the amplifier, and how important the amplifier is and how much more important the amplifier is actually than the guitar, because it's the last thing that you're going to end up hearing in the sequence. My guest today is Mr. Robert Lippett, who is an amp tech, and we're going to be diagnosing some amps, and we're going to start with a little bit of history and understanding of how the amplifier came about, which is actually relatively simple. We needed one, and we needed more volume, and public address systems were being made for vocalists, and they said, why don't we make something for guitarists? So let's kick off with this beautiful amplifier. This is a 1953 Fender Twin. This is early 50s were still relatively early years for the amplifiers. The first amplifiers that were made in the late 20s, early 30s were roughly, what do you figure, Bob, 3 watts, 2 watts, 5 watts?
They started there. They went up to maybe 10, 12.
Yeah. This one, in actuality, being a 1953, is a whopping 15. That's 1.5. This didn't turn to, what was it, 45, 50 watts around 1955, I think, is when they made the first conversion for the Twin to go up. And if you notice, we have no effects. Effects weren't really going yet. No one had them in the amplifiers at that point. Reverb that we will see on the more modern amps that we have sitting in front of us. And the middle one not being so modern, being a 1966 blackface deluxe reverb, but the reverb wasn't added in until the early 60s, let's say 63. I think they started just before, or maybe not. Did the blonde ones have reverb, or was it?
Some of them, yeah.
But once the blackface came in.
Yeah, I mean, it used to be the deluxe, and deluxe goes back to the 50s
right.
in different variations, and then it came up to the basic.
The one with the mods and, and the reverb and
the tremolo. They had tremolo first before they had reverb.
That's right, tremolo. We should actually demonstrate that, but we'll get to that in a second as we get into modern land. Let's start off with, first of all, we just needed 15 watts. If you were looking up here, you would notice that it says there's 2 inputs for instruments, and there's 2 inputs for microphone. So at the time, I believe that a lot of this Twin is a an overall word that's used as in Twin having 2 speakers, in Twin having an amplifier for your instrument and an amplifier for your vocals, or an amplifier for another person to be in. Of course, once you regulate the volume of one instrument, the whole amplifier, no matter what else is plugged into it, will be run off of that potentiometer of the instrument. But you could feasibly use this as a single act. Go out there with a guitar or an accordion, right, Bob? And a vocal.
Sure.
Kind of a thing, pre-public address system. So a lot of this stuff was also being designed in a more multi-use fashion before it started to basically focus for, and then in lack of popularity, and that's more in the United States, I would think. I don't know about how this was working in Europe, but the accordion, other electric instruments that would be used under this. And then we started realizing that we needed amplifiers in specific for acoustic instruments versus electric instruments because of the way the equalization points are designed. I'm going to throw it over to Bob. Let's see what Bob has to say about this 53.
All right. Well, we're going to give you a couple of tech pointers. And you hear all the time that, these things have lethal voltages. I don't know if we can see the meter, but I'll read it off. So, we turn the standby to... Oh, okay. A little
It's an old amp there, Bobby.
So these are called filter capacitors. This is the rectifier tube, which converts AC to DC. You see 2 diodes. Each one of these is a diode. And basically, they go into the filter caps. It smooths out the DC, and it's actually stores. And these are like batteries. So when we go to measure the voltage, we're a little over 400 volts. Okay? You get zapped by that. You'll know it. And when they say lethal, I mean, I still get zapped every once in a while, it happens to me. But you need to remember, as soon as you feel that power, you could pull yourself away as soon as you can, because at some point, some people can't, and they just get electrocuted because you get stuck.
Yeah.
You stick to it, and you can't move. It freezes your muscles. So basically, on the output stages, you get about 400 volts, and then you go to the preamp stages, and you get less. There's 329, and as you go down, there's 290. And if you look at a schematic, they have A+, B+, C+, and D+, and they go down the line, you get less and less voltage because the preamp stages don't require the amount of voltage and power that the output does. But still, it doesn't matter. They are lethal voltages. And you can go on, YouTube or various blogs and forums, and they discuss this stuff all the time. But you can work on these yourself. But just be aware that you keep the amp unplugged, and when you turn it on, after you turn it off, these caps retain their power. And don't let it fool you. They can retain voltage for years after you turn it off. These small little guys, these are called your coupling capacitors. And these couple the stages. So basically what you have, if you have 300 volts going to a tube, you can't go directly to the next tube with the voltage. You blow the tube up. So what these capacitors do is they block the DC and they pass the AC, or the AC is the signal. And basically it goes stage by stage and the same thing happens. And you have different values. They can give you different, a little more bass, a little more mid-range or whatever, but they're selected to give you specific sounds and the tone control. I'm not going to get too technical right now, but they're your basic components, and this is what they do. I could go into explanations, but like I said, if you go on YouTube or some forums, they'll very thorough explanations on this. But it's the high voltage you really have to worry about.
Now look at this circuit board. Now, if you've ever taken apart your TV set or opened up one of your pedals for your guitars and to change the battery, and you'll notice there's this pretty little like mint green circuit board with all these beautifully laid out transistors and resistors due to modernization and the fact that a lot of circuit boards are now being assembled by a computer, which now they can get, that's why things get real small, like this wonderful little tuner that now the technology has pretty much gone through a less than $15 device. Get ready for that? I paid $100 for my tuner back in the 80s because of the quality of calibration and stuff. Now everything's digital, everything's being made by a computer, whereas we look at this, and I don't want to put my hand in there after Bob's suggestion not to, but if you can see, as you can see, if we get a close-up in here, this is really very early hand wiring, and the hand wiring is very simple, well designed, all in a nice little. Now we can't see the other side of the circuit board. There should be like a pattern back there.
No pattern. These are just point to point. These are little like eye loops, and basically they solder and then just put the components, and basically that's how it's made. There's Fenders up until they changed from here to a printed circuit board. Basically they're all designed the same. They use what they call fish paper, or they're usually two layers. One that uses an insulator from the circuit board, and another one on top. But sometimes they'll run a wire in between over to a point, usually a high voltage wire.
Well, can't the layers separate over time due to humidity and?
Well, they do that, but yeah, well, that's what I say. They use two layers and they have screws. So sometimes if you open the amp up, they're warped.
Yeah.
Yeah, but that doesn't affect anything, because it's all point to point. So you have these little eye loops, and that's how everything is connected. So there's no printed circuit at all, and that's one of the reasons why Fenders last so long, because there aren't any printed circuit boards. Well, amp pegs have circuit boards, and they last a long time, but at this point in time, everything's really, really brittle.
Now, old Marshalls back in the '60s and stuff, they'd be using some of the same materials. They
were hand wired, and then soon after they had printed circuit boards. But the boards are so small that generally you didn't have problems.
Now, I know that in the '70s, due to rectifier tubes creating sag in overdrive signal, that they went to transistor rectifiers.
Well, diode, right.
Yeah, now that was the early '70s for Marshall?
Marshall, they didn't use tube rectifiers too long. They knew better because the amps would just plain blow up on tour because they get to be so powerful. And I mean, today you'll have the Mesa Boogie double or triple rectifier. And you know, they're going back to that whole thing, but they normally have a built-in solid state diode circuit, so you can switch, you can mix both, or just switch to solid state.
Well, that's what the rectifier tubes are all about. It's not computer modeling, but actual, in essence, analog modeling, like this Seymour Duncan amp over here. I know I'm jumping a little bit too far ahead, but as you can see, I can put different modules in there. I was going to put that down. You can see there's little tubes, and over here there's a cover. And inside here, as you can see, I'm reaching my hand in here, but the amp is off, and there's no diodes or anything in there. Which one did I have where? I had this one here. I can change my preamp section completely. That's why I have these other modules over here. I can change the preamp section completely. But before we get into this kind of modeling and what Mesa's doing with the triple rectifier, let's move up the years. Let's get into around 1956, 1957. At that time, there was a gentleman named Ray Butts. You see one of his inventions on Gretsch guitars all the time because he was the one that made the first humbucker for Gretsch called the Filtertron, and then designed the Hylotron, which is a single coil that fits in the same amount of space as the Filtertron does. And besides making wonderful things for manufacturers and being a wonderful inventor, one of the things reasons Gretsch hired him was because of his amp expertise. And in his amplifier expertise, he made the Butts amplifier, which was the first one to have effects, reverb, and we call it tremolo, but it's really vibrato, isn't it?
That's what they normally call it. Depends how the circuit was wired. Initially, it was wired into the output stage where the bias circuit was on an AB. AB series amp, and it would modulate the amount of power going to the tube.
Well, I think a lot of vibrato and tremolo gets mistaken. They call this a tremolo bar, but it's really vibrato.
Right.
Vibrato goes up and down in tonality, where tremolo goes in and out in volume.
Right.
All right, kind of a thing. So it's really different, and sometimes they call the units on the amps vibratos when they're actually tremolos, and they call the guitars tremolos when they're actually vibratos. But this is what happens when musicians start talking the talk as opposed to people in science. Remember, humbucker is not a term in Latin. This pickup now bucks the hum. I mean, how much redneck could you get? You know, an explanation of it.
Well, your Fender, they call it Tremolux, and then they call it Vibrolux.
Yes.
So, you know.
Yeah. So, you know, which one's which? So at any rate, Ray Butts started putting these effects into the amplifiers, and who had them? Everybody. Scotty Moore, if you never heard of Scotty Moore, that was Elvis Presley's guitar player in the 50s and early 60s. Chet Atkins had a Butts amp. Everybody who was known to be anybody wanted one of these amps. It was like when Marshall came out and they hit big, everybody wanted a Marshall. Well, same thing with Butts amps. So Fender goes, well, wait a minute, why can't we produce an amp? Because these were all being handmade by Ray himself. Why can't we go and produce one like Henry Ford? And they did. And what I'm going to ask is let's view this front amp here, the sitting center. It's a deluxe reverb. I'm going to take this off. This belongs to the Mesa, and this switch belongs to the Seymour Duncan. There's a little foot switch to get you into vibrato and reverb. Do I have it upside down? Yes, I do. I am so sorry. I'm a bad boy. So you could access the reverb section, you could access the vibrato, and with single channel amplifiers, besides the effects, even going back to here, and going back to Charlie Christian, if you turn the amp all the way up and get the preamp section as hot as it can get, and you turn the guitar all the way up, you step on the volume steps on the sensitivity of what the instrument is overloaded with mid-range. And that step of sensitivity is what gives you overdrive. So when Charlie Christian was playing, he was probably playing through a very powerful amplifier at the time, something maybe between 3 watts and 5 watts. And the gentleman wanted to be heard. But when you heard Charlie play, everybody went, that doesn't sound like a guitar anymore, but we like it. And what it sounded like, at least to my ears, was that grizzly saxophone when someone's really pushing a lot of air into the saxophone, overdriving basically the saxophone with air. Now the guitar was overdriving the amplifier because the amplifier is also mid-range sensitive. So cranking it up, that's why a lot of amps in the early days, if you notice, do I have a mid-range on this? I don't think I do. Do I?
Not in the early.
Volume, treble, bass, yeah. There's no mid-range control on this Deluxe. All right? Leo Fender said too much gives them a little too much, and I don't want to get them too crazy. A lot of overdrive and distortion wasn't being really well accepted in the late 50s from the record companies. They didn't think they could sell it. Surprised some people like Link Ray had made it through. There were a lot of instances where they got more of this overdrive, but that's why we eventually ended up into getting into channel.
Well, you know the story behind the distortion.
What's that?
I forgot who was recording, but they brought an amplifier in, and the guitarist had to play through, and one of the power tubes fell out. And all they could get was distortion out of it.
That was
right.
Train kept it rolling all night long. I forgot who the guitar player was. I know Aerosmith did a remake of it. But yeah, the story I heard was his power tubes were half dragged out of the amp being on the road and in the back of a truck, and they didn't know what was wrong, and no one knew how to repair amplifiers. Right. And that was like the coolest overdrive of the overdrive.
They had to go with it, and then it became popular.
And then it started to become popular. And what happened with strings, by becoming more magnetic for more clarity reasons, magnetism offered more clarity to the instrument, so it enunciated better, but it also made, by being more magnetic, made the overdrive come up faster. And as they added more power to the magnets in the pickups, this is where overdrive went over the top. So in the old days, you'd be basically your neck pickup with the volume rolled down until you got a clean sound, and then you roll your volume up all the way, hit the bridge pickup, and the old amps would start to overdrive. And now, with the more magnetic strings and the more pickups, the more magnetic the pickup, the faster the amp overdrove. But going from clean to overdrive could be a little bit of a hassle as far as keeping volume consistency going. So in the early 70s, we went one step further. We added channel switching. But now we went from Class A amplifiers to Class AB amplifiers. And I'm going to let Bob take over at that point.
Well, the basic Class A's were a lot smaller. Those were the early ones. Then they came out with what they call cathode biased amps, and they were more powerful, and they sound good. But then they went into what they call a grid bias, which is adjustable. Cathode bias, there's no adjustment, but when you got into grid bias, then you got into either. They didn't really match tubes back then, and it was done by ear. So, now everybody's a bias fanatic.
Right,
but when you use the grid bias, then you start getting the higher power. And
now, this bias cannot be adjusted on this amp, right?
No.
But now, can the bias be adjusted on the 60s?
Sure.
The 60s amps have bias adjustment. And obviously these guys, the Mesa and the Seymour Duncan have
Right.
have
But there
bias.
were different configurations. Later, Fender came out with what they call a balance a tube balance. So one bias was fixed, one voltage was fixed, and there was a hum, and you just turned the pot till the hum disappeared. But that's not really biasing. So what I do is I modify that back to the old circuit, so you get a true bias circuit. It's called blackface, and a blackface mod. But generally, you can't really do much to a Fender amp that has the balance. You can't really adjust the bias, but they work by a voltage. And for years and years, nobody even knew what the hell bias was or really cared. And you know, generally, the amps ran cold enough where the tubes didn't burn out, and they still sounded pretty good.
So now we have what they call channel switching. Here, this what this pedal does on this amplifier. If I turn the amp back on and we take a look at the front of the Seymour, you'll notice that the green light is on right now on the front of the amp. That's what they call the clean channel. And now we're into the overdrive channel for distortion and stuff like that. I could model this amp to work like a Fender. I could model this amp to work like a Marshall by changing these modules. All right, you've got these little modules. You can change. You can change tubes. Okay, so you don't have to do a 12AX7, which is more powerful of the preamp tubes.
Right.
What's the weakest, the AU or the AT? So the AT7.
AT, AU, and an AX.
Now AU they use a lot on reverb, don't they?
Generally, the AT, the AX, let's say 100%. The AU is 70%, and the AT is 50% power. So that's how they react. And some guys like to, even if it calls for an AX, play around with an AT and an AU, because you can turn the gain up higher and with a lower power.
Right. And on at the same token, if you take an AX7 and run it into the reverb circuit, the reverb can help you overdrive.
Actually, the reverb sounds better with an AX7.
Really? But
generally, they use ATs, and a lot of guys upgrade to an AU. But generally, it's an AT7 along with the phase inverter, which you can replace with a 12AX7.
Now, about 10 years ago, Randall came out with an amp. I don't know if Dimebag Darrell was using it or not, but I know the gentleman, I'm spacing on his name, from Metallica, yeah, the lead guitar player. They actually had big modules that you could, you know, this is your clean channel module, boom, and this is your distortion module, and you had options on what kind of clean channel you wanted and what kind of distortion channel you wanted. Again, one step further in this format.
Right.
And then we get into more Mesa Boogie, where if we go to the Mark IV, would you grab that, Bob?
Yes.
I know you can't see it. Well, before we show them that, why don't we grab this? Could you grab that piece of paper off the top of the amp?
Oh, okay.
And let the people see that. I think there's a little,
there you go.
Yeah, just let them see that. What you're looking at is, believe it or not, the dials on the front of the amp and the dials on the back of the amp. So this one is the front, this part is, where's my fan? Here, there we go. That's the back of the amp. Right. So look at all the crazy controls you got. And then in the directions they say, don't use the active EQ, because the active EQ you'll get addicted to. So to use it very sparingly, all right? But we have this push-pull pots on this. A potentiometer is a knob, okay? And a push-pull potentiometer is one that you can push, you can pull on it, and it will do a different.
It has a switch.
It has a switch built into it.
Right.
I should be showing you on the Mesa, but the Duncan doesn't have any, but the Mesa has a bundle of them. And then if you look at the Mesa pedal board, I got 3 channels. I got a lead EQ bypass. This is like incredibly designed. They now have a Mark V. I don't know. I've always just kind of, as opposed to thinking about it, just kind of went with my ear when I play this amp. I don't know what else to do. You could think about it 100 different ways, but thinking about it and actually hearing it after you thought about it doesn't always sound good. So, as any musician, always use your ears, Luke. Use your ears, as Obi-Wan would say, when you're dialing these amplifiers in. And going into the last of it is the more modern, which we didn't bring because my back couldn't take anymore. And I don't own one. I'm a very analog-y kind of guy. I never got into samples, whether it was a synth or nowadays amplifiers. So we have those, and we have another amplifier we need to talk about, the acoustic guitar amplifier. And the reason why we talk about an acoustic versus an electric is on the acoustic, the mids are all rolled off, because the acoustic doesn't need the mids. You need the mids to overdrive, to distort, to do all the cool things on an electric. You need those mids, but you don't need them on an acoustic, which is why when you take an acoustic and you plug it into an electric guitar amplifier, it sounds more like an electric guitar than it does an acoustic guitar. So we have what they call acoustic guitar amplifiers, and I don't have one because, one, my back can't take it, and when I go to a gig where I have an acoustic and an electric, I like to let the mixing board do all the acoustic work. So I just run a direct box right to the mixing board, and I let the mixing board be my amplifier, and what I listen to it back on is on the monitors. So there's that amplifier, and then there's the sampled amplifier, where like Fender makes one where you buy the I don't know if it's called the Evil Twin or what. There's a sampled twin twin reverb amplifier, and you can get from different output circuits.
Well, it's DSP, digital signal processing.
Right. So instead of using a 5U4G, for instance, they'll use a different.
Right, but you get clean American, and you get overdrive British, and everything in between.
And they do it by sampling the sounds of the different tubes.
Right.
You got 6 V6 output tubes. Right. You have 6 L6 output tubes. You have EL84 output tubes, which is what, Vox driven, isn't it? 84s.
EL84s, sure.
Yeah, kind of Voxy, and then EL34s, which are Marshall tubes.
Right, British.
I have EL34s in this Seymour Duncan amp. I have 6 V6s in this Deluxe. I have 6 L6s in this Twin. And I have a combination of EL34s and 6 L6s in the Mesa because they allow me to put 2 different kinds of output tubes. And then these powerful amps, these analog amps, you can actually cut the power in half into a quarter, so you can shut down 2 of the tubes out of 4 because they're 100-watt amplifiers. They require 4 tubes, and I'm running out of time. So I'm going to let it kind of end. I want to thank Bob for coming down and giving us his 2 cents worth on amplifiers and how the history and how they all work. And I want to, as usual, thank my usual host for letting me substitute in for today. And I hope you all had a wonderful time and get to see you next time. Let me see if I can turn an amp on fast enough. Is this thing on?
Well, it's too late now.
Oh, it's too late now.
We'll be back with more, though. There you
Goodbye, everybody. Goodbye. I'll see you next time. How's that?